Hi guys, so today we're going to take a look at question 3 of the 2016 exam, paper 1. Okay, so part A, we have a function f of x, which is 2 over e to the power of x, and g of x, which is e to the power of x minus 1. Now we want to complete the table below and write our values correct to 2 decimal places where necessary. Okay, so we need to fill in this table when x equals 0, x equals 0 0.5, x equals 1, and x equals ln of 4. Alright, so let's just start by writing our functions. So f of x equals 2 over e to the x, and g of x equals e to the x minus 1. So we want to calculate the values of f of x when x equals 0. So that is just 2 over e to the 0, which is 2. 2 over e to the 0 0.5, which is just 1.21. E to the 2 over e to the 1, which is just 2 over e, which is 0 0.74. And 2 over e to the ln 4. Now you can just put this into your calculator and it'll give you the answer, but if you notice, you can kind of see a little trick. E to the ln 4 is just 4, and so it's just 2 over 4, so it's just a half, 0 0.5. Okay, and now doing the same for g, e to the 0 minus 1 is just 0. E to the 0 0.5 minus 1 equals 0 0.65. E to the 1 minus 1 is 1.72. And e to the ln 4 minus 1 is, again, just 4 minus 1, which is 3. Okay, very nice start to the question. Okay, now on to part 2. In the grid on the right, use the table to draw the graphs of f of x and g of x in the domain 0 from x to ln 4. Okay, so, well, we've already calculated the values of f of x and g of x for 0, 0.5, 1, and ln 4. Out of just interest, what is ln 4? It is 1.38, so it would be somewhere around here. And now we can just, draw a graph. So when x is 0, we'll draw f of x first. It's 2. When x is 0 0.5, it's 1.21. So something like this. When x is 1, it's 0 0.74. So something like this. And when x is ln 4, it's 0 0.5. So something like this. And now we just connect the dots here to give ourselves some sort of curve like this. And then this is what f of x looks like. Okay, and now let's do the same for g of x. Well, when x is 0, g of x is 0, so we draw a dot here. When x is 0 0.5, g of x is 0 0.65, so somewhere like here. When x is 1, g of x is 1.72, so somewhere here. And for x is ln 4, g of x is 3, so here. And now again, let's just connect the dots here. So something like this. And now it doesn't need to be perfect. You just have to get the right kind of shape, like, it's curving upwards and f of x is curving downwards. And the most important thing is that it travels through those 4 points. Okay, now on to part 3. Use your graphs to estimate the value of x for which these two meet. So now, if these two are equal, well, that's the point at which their graphs meet. And so that would be this point here, somewhere around here. And what value of x does this happen? Well, if we just go from this point down to the x-axis, we see that it's somewhere around here. And this would be, something about 0.6, let's say that's about 0.65, okay? Approximately 0.65. And now you don't have to be like extremely precise with this. As long as it's, so there's 5 kind of squares between 0 and 1. And it's in the 4th square, so it's between 0.6 and 0.8. Honestly, as long as you've got it in that square, 0.6, 0.8, you're probably going to be fine. Don't get caught up in being completely exact. Okay, and now if we then look at part B, then we want to solve f of x equals g of x using algebra, so basically solve it exactly. So we kind of quote unquote solved it with our estimate. But now we want to solve it properly. And the way we solve it properly is just letting the two functions equal each other. So we're letting f of x equals g of x and then solving for x. Okay, well, so this is the same as 2 over e to the x equals e to the x minus 1. Okay, well, having an e to the x on the bottom is not really very nice. So let's multiply by e to the x, and we get 2 equals e to the x by e to the x minus 1 times e to the x. Now, e to the x by e to the x is just e to the x plus x, which is just e to the 2x, just by using our rules of exponents, minus e to the x. And now this might look a little bit weird. How might we solve something like this? And the trick is to realize that this kind of looks something like a quadratic equation. We have, if we bring the 2 over, then we get e to the x squared minus e to the x minus 2 equals 0. Because remembering our laws of exponents, this is equal to this. And actually, you can see it straight away by just looking at this part. We've got e to the x by e to the x, so that's just e to the x squared. Okay, and now let's say we let y equal e to the x. We'll just substitute in y wherever we see e to the x. Then we'll get y squared minus y minus 2 equals 0. And now we're pretty sure we could solve something like this. So if we use our minus b formula, y equals minus b plus minus the square root of b squared minus 4ac all over 2a. Well, a in this case is 1, b is minus 1, and c is minus 2. Okay, and so now if we just put that into a calculator, we'll just get 1 plus minus, so y equals 1 plus minus 1 squared minus 4 by 1 by minus 2, which is just 1 plus 8, all over 2 by 1, 2. And the square root of 1 plus 8 is just the square root of 9, which is just 3. So 1 plus minus 3 all over 2. Okay, so y either equals 1 plus 3 over 2, which is just 2, or 1 minus 3 over 2, which is just minus 1. Okay, well now we got to remember that y is e to the x. So e to the x equals 2 and e to the x equals minus 1. Now we know that e to the x can't be minus 1 because e to the anything is going to be positive. So it can't be this one. So it has to be e to the x equals 2. Okay, and now we can solve this. If we just, so e to the what equals 2. And that's the same thing as writing x equals ln, or log e to the 2. Because log e to the 2 is just saying e to the what equals 2. And that's what we're trying to find out. It's x. And so we can solve this. So this is ln2. And we can just put this in our calculator. ln2 equals 0.693. And that's our answer for x. X equals 0.693. And our guess was about 0.65, so we're pretty close. Now, if the answer here was 2.5, you might think, hey, I think I might have got a problem here somewhere. So this estimate kind of helps you as a guide. And then this actually helps you as a guide for your estimate. So let's say if your estimate was like 0.4, you might think, oh, maybe I've drawn this graph wrong. And you've got to remember that, these questions are often related to each other. So, use them to use the answers of one to guide you on the others.